taken for an object being job and falling under gravity. Okay.
Sir, what are you saying?
Nothing, dear. I didn't say anything.
I thought you gave a problem.
Yeah, this is the problem to solve. So here, if you have graph paper, okay. If you don't, it's okay. You can draw with a scale and pencil or whatever you want in your notebook itself.
So, are you sharing your screen?
I am.
Sir, but I can't see.
Is my screen visible to everyone?
Yes, sir, it is.
Guys, it's visible, right? Okay. Adit, you can do one thing. You can refresh your screen, refresh your page or something.
Okay, sir, I got it.
Okay, so shall I scroll a little bit? I interact questions here. Plot a graph of distance fallen vertical axis against triangle. So this says distance is on vertical axis, that is y-axis. It's 17 today. What happened? Okay.
Sir, am I audible?
Oh, you're present.
Sir, actually, I was having a lot of internet issue. I'm in my relative's house. I had to do a lot to just come on to this other floor, and so I was just checking on the internet where it is on which room and all. So it became late. Sir. What were you saying in this 20 minutes?
We were just discussing about summer holidays.
What's this question?
And now we started with the question. Okay, guys.
For motion chapter, only this much, only questions are left, or more is there?
Still so much. We are going in deep detail.
Means every day you're asking questions. So doubt.
I have infinite questions. My questions won't be finished.
Let me know, sir.
You know what to know.
What's that?
What you said, your voice was like.
I didn't get you, sir. Can you repeat that?
No, what you said, I didn't understand.
Both of them are not able to hear each other.
ठीक है, सॉल्व करो. Draw a graph. Maybe not today. Next class we will derive those motion equation. Then questions will be tougher. It will be more interesting actually. When we derive those motion equation, it will be more interesting. Because that time you have to think, okay, which equation to use here. My favorite topic in physics is kinematics, which we are studying. Yes, people. What's the progress? Are you doing or feeling sleepy?
They're doing, sir.
What about Adya?
So what are we supposed to do?
Just Bharatanatyam. First thing, see, draw this graph, then explain why you can get straight line. If it is not there, then okay. If it is, okay. Explain why.
Okay.
And calculate the velocity of object after 1 second. So after 1 second, any number.
Okay. Sir.
So, like, what do you mean, like, calculate the velocity of an object after 1 second, like, average velocity?
See, what graph you got? Is this the straight line? I don't think it will be straight line because the values are differing, right?
Yes, sir, it's not a straight line.
Okay. So to get the value of this one, we will draw a tangent. So let me just draw a graph. Everyone has taken question, right? Shall I start drawing?
Yes, sir.
Sir, just the third, I mean, second one I have to just take it. I mean, second point, sir.
Just let me draw this. Okay.
Okay, sir.
Take this.
हाँ sir, done sir, done sir.
So I want what is the minimum value here? 0.5, 0.5, 0.52. It's going till 1.4. So if I take 0.2, 0.2, 0.6, so approximately I can get it. Okay. So if I draw 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4. Let me take a more distance. How many other? 1, 2, 3, 4, 5, 6. So 3, 4, 5, 6, 7. So 2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4. Similar way, this will be the distance. What are the values on top? It's 10, right? So if I take 1, 2, 3, 5, 6, 7, 8, 9, 10, it will be easier.
Yes.
6, 7, 8. Oops.
Sir, that whole that questions maybe you can like select it and then you can just drag it up, sir. See, sir, that one only, sir.
Actually,
Sir, I'm almost getting it.
like 9, 10.
Sir, for like Chanakya means like physics. I have kept different graph books, sir. Sir,
Yes.
I have kept different graph books, sir.
Very good. We'll use it, but not much. We do. I think so. You need in maths only. We have
For
one or
both Chanakya maths and physics, I have kept.
physics. Will have 1 or 2 question maths. Okay, so what is the first point? Just tell me the first point. 0, 0. Okay. This one. Then the next point. 2 and what is the number? I don't want to scroll up. 2 and what? What's the number? Can you not hear me? What about the others? They went sleeping.
So your voice is breaking a bit for me.
Am I not audible?
No, sir, you're audible clearly.
Acha. So are you all sleeping? Tanvi?
Sir, two.
Tanvi, are you with us?
Yes, sir.
Super. What about Vishnu?
Yes, sir.
Okay. Zoya?
Yes, sir, I'm there.
ठीक है. So what are the values? Come on, tell me here. What is first point? 0, 0. We got it. Then next. Quickly tell me. What is next? 2 and what? This is distance.
0.63.
0.63. So this will be 7. So 63 will be here. So maybe this point. Then next. What is next point? Yeah, I will search it. 4 and 0.9. Six and 1.8. Next, 8 and 1.25.
Yes, sir. Sir, we are on that same graph only, right? So you did not make another one, right? Because like I got disconnected for a while.
We are the same. 10 and 1.4.
Okay, sir.
Okay. This is what the graph I got it. Maybe
Yes.
it will be different because not exact measurement. It should follow.
Yes, sir, but then it's the same, sir.
It should follow like this, I think so. Okay, whatever. Fine, whatever it is. So when you from that point draw a tangent. Change color. Draw tangent line. It's not touching. Okay. From the starting point.
Sir, what do you mean by calculate the velocity after 1 second?
For that only we are drawing a tangent. See what we are doing? We are drawing a tangent here. This line. So at what point it is meeting here? It won't be exactly here. It might be here somewhere. You have to start from this. Actually, if we have proper graph, now we can start from here. So if this curves, this draw from here, it won't be exactly here. It will be following from here and joining somewhere here. So let's assume this is 0.5.
Sir, isn't it 6 meters per second?
This is meters. These are time.
Yes, sir. So after 1 second is 6 meters, right? It travels.
You know, we need to find velocity. See what they're saying? This is not straight line. Okay, let's go with one by one. Draw properly on graph. Okay, use scale and pencil with proper marking. Then next is explain why your graph is not straight line. Obviously, the values are differing. Why it is not straight line?
Yes, sir, because it's not a uniform motion and the values are different.
Exactly. So values are
Yes, sir,
differing.
it's like at different intervals of time at equal intervals, like at equal distances, like unequal intervals of time.
It's not a uniform motion. Now, when we draw this tangent graph, so some points will get here. Let's assume this point is joining at some not exactly 10 and not even 9. So let's take it as 9.5. And this point is joining at not 6, then not 4, approximately 0.5. It depends upon your graph, what you're choosing. And what is this point here joining this? If I draw a straight line from here, if I draw a straight line here,
Sir, the distance is 10, right? Why did you take it as 9.5?
no, how I'm drawing here actually, see, I'm drawing a tangent line. This graph will be like this. Okay, so when I draw a tangent line, it won't be exactly at this point. Here I'm showing a straight line, but it's not exactly straight line, this one. So this red line is joining at somewhat, I'm assuming it's joining at above 9 and it's not exactly touching 10, approximately it's touching somewhere here.
Yes,
So what is tangent? If I show you, when I'm drawing a curve, and once I draw the straight line like this is your tangent to that point. This line is tangent line, which is touching at this point. There is a tangent drawn on this curve. This line is called tangent. So when we are using exact marking, exact labeling, so approximately I'm getting this point. It's not exact. It's up to your calculation how we are getting. I'm just assuming here I'm getting here 9.5, not even 10, not even 9. I'm just assuming it's between 9 and 10, that is 9.5.
Yes, sir.
Same for this one, 0.4 and 0.6, I'm assuming as 0.5. And this is obvious 1 point. This one is 1.4 fixed value. Now, what we have to do here, just whatever value you get, you use the same method, same way. I'm just showing you one number. Okay. So what was that distance by time? So top point is here 9.5 or 9.2, whatever, 9.5. Bottom point is 0 in this y-axis, and here sorry, it is 1.4 minus.
So isn't bottom point 0.5?
No, it is for time axis. See here, this is for time axis. Y-axis is 9.5 and 0.
Yes, sir.
Distance axis. Time axis is 1.4 and 0.5. 1.4 minus 0.5. That is 9.5 divided by how much? 1.4 minus 0.5 is 1 point. How much?
0.9. 0.9.
So if we divide, what are we getting?
So like almost 9.5 meter per second.
Sorry, 9.5 divided by 0.9. It's approximately 10.5. See, everyone, basically what are we doing here? We are finding velocity after 1 second. So we are drawing a graph, we are choosing a point for after 1 second, we are drawing a tangent on that line after 1 second. Okay, so
So after 1 second,
we are drawing a tangent. See, after 1 second, it's
like
joining here.
distance.
After 1 second, so at this point is joining. Our line is joining at this point. Wait, let me scroll up. After 1 second, line is joining at this point. So, in short, what we want top point of that triangle. Bottom point we already have on x-axis. This 2, and y-axis is 0 to whatever value we are choosing it here. Whatever value we are getting here. Everyone, are you able to understand?
So I didn't understand why we took it from 0.5. Why can't we take it from 1? Because it says after 1 second, right?
No, that is for seconds. Array, you're saying this value, 0.5 value. That's what you're saying.
Yes, sir. I'm saying that why can't we start from 1?
Okay. After 1, we drew a tangent line, right? We drew one tangent line like this. Okay, I know that it's not that clear. You're not able to understand by the drawing. How to make it clear? I don't have scales actually. Do we have scales here? Insert something, table, file, print out, online, audio, symbols. No. a scale here, right? You do in your notebook properly instead of here. It's simple. After 1 second, your tangent should touch after 1 second. Any point after 1 second. There will be a graph. This is your graph. After 1 second, touch anywhere like this. So wherever it is joining, mark
Yes,
those
sir, like,
points.
why is it like touching from 0.5?
It is not touching. We are extending their line. From after 1 second, we are touching this tangent to this point. This is your touching point. It's after 1 second. So when we are extending this line, it is touching at whatever point we are getting, 0.5 or 0.6, whatever it is.
Yes, sir.
So this is your initial value. Final value is 1.4. 1.4 minus 0.5. Sorry. And 9.5 as I took here. I am assuming it's 9.5. It might be 9.2. It might be 9 for you. Whatever.
Yes, sir, like I was assuming.
Yeah, I have assumed these values because I don't have scale. So I assume this value. It might be this one. So it might be different, little bit 0.5 difference or somewhat 9 or 10. You might get 10 also. Check what values you are getting.
So we're getting something like 10 point something.
Cannot exceed 10 because join this point. This is your end point. Draw a line at 1.4 straight line. That is your end point. Cannot exceed 1.4 line. This is your end point. When you are touching it 10, what is the last point? 10 and 1.4, right? That is your end point. It should not exceed that.
Yes, sir, I'm saying about the answer 9.5 by 0.9.
Then okay.
Yes, sir.
So it's something like 10.0.
No problem. Whatever it is. Depends upon your graph. I'm getting here 10.5.
So can we have a quiz?
Just now we studied this one.
No, sir, no quiz.
Yes, quiz.
No
Sir,
quiz.
please
We'll
quiz.
study.
Sir, I couldn't attend those quizzes, sir. I also told you the reason. Please quiz.
Yes, quiz.
Okay. Wait. From this one, I want to give you one more thing.
One question only we took full class, sir. Another question means no quiz, no, sir.
Okay. So acceleration is change of velocity by time, which is equals to slope of, that's what we did just now here, slope of this one. Slope of tangent, will it be equals to rise and run? What do you mean by rise and run? Let me draw here and explain.
There is like a major difference between like it's slowing down and rising.
So suppose our graph is going like this, and this has become constant velocity. Right, this is now constant velocity. So if I draw one line, wait, this scale, straight line. This is velocity. This is time. And what we are drawing this line, that is tangent line. And this is called rise, which we drew here, that 1.4 line, that is your rise. And this is run. Understood? What is rise and run?
Period of time, how much it traveled.
Yes. This rise is that 1.4 line we drew, right? From 10 to 1.4, one line we
Yes.
drew. If I show you above, this line is called rise. And
So on that 0.6 is like
yeah,
yes,
that is
that
called
one.
run.
Yes.
So to remember this one, slope of tangent is rise by run. Means in short, difference in those points. Now clear?
Yes.
Okay, I want to derive this formula, so I gave those things first. What happened? You got tired with the one question itself.
Or we want to.
Okay. ठीक है. What about Anshul? You were there in last quiz? No, who was not there last quiz?
Sir, I was in this.
Yeah, wait. There will be now onward, there will be one punishment. Those who don't attend the quiz.
Sir, I actually gave you a particular reason. Sir.
Yeah, that is okay. The Anvesha was there, Sarasya, Stacy, Aisha, Nitya, Zoya, Lalit, Vedika, Palak, Tanvi, Jashmi, Ayush. Anshul was not there. Yes, Anshul. Mr. Anshul. Ah, he left it. It is very bad. I called his name, he left. Mr. was not there. Okay. He has a reason. Tanvi, yeah, you were there. Correct. Manugna,
Yes, sir.
you were not there in last quiz.
Sir, I was not feeling well, so I left the class in middle.
Oh, okay. Now you're okay?
Yes, sir, I'm fine.
Sohan, did you solve your problem? You're facing some issue, right? Last time? Okay, then let me post a quiz. Anshul, yeah. What is this? Question in straight line or one dimension. Today we'll have some picture. No, not straight. Okay, but this graphs you haven't studied, no? Will you try it? I haven't taught this graph, but will you try this?
Half no, half yes.
I don't know why even I thought the same thing. Sir. No, sir.
Still riding a bike now. Okay, this you can do.
And then we'll be able to do it. Like we can just give an example right now and then we'll be able to do that.
No motion in straight line. We'll go motion in one dimension only.
Sir, I did not understand, sir.
What did you understood?
Like how to do, sir. That part.
Which one? This question?
Yes, sir.
See, actually what we are doing, we are drawing a straight line there. I mean tangent. From after, we are joining, what's the question here? 1 second, after 1 second. So after 1 second, we will draw a straight line. After 1 second, and we will join that. So as you see here, this is my straight line joining after 1 second, any point, and will extend till this, it touch this line. So it's touching for me, it's almost here.
Yes, sir.
9.5. Then I'm extending that line at this point, which is touching approximately 0.5, I assume. So I got this triangle like this. So this point is 0.5 and this is 1.4, and here it is, I assume this 9.5. But you don't assume, you get exact values. It's
Okay, got it.
okay. So just difference on those, rise and run. We give our name as rise and run. Understood here? So let's have a quick quiz. Shall we have power-ups?
No, sir.
Is this time? Let's try with power-ups.
Yes, sir. Yes, sir.
Let's see who's lucky, who is
No, sir.
Sir, I am neither.
Sir, new power-up system, sir. This time you get 3 power-ups, sir. Instead of 1.
ठीक है. Come on, join karo quickly.
Yes, sir. Let it load, sir. Because it takes a lot of time to load only.